Hi, welcome to another mini lecture on pre-calculus. Today's topic is change of base for logarithms. So I have a few questions from this section. Logarithm of 7 in base 3, logarithm of 1/5 in base 1/3, 1/9 in base 8, and so on. Logarithm of 4 in base 1/7. They're all about the same thing. We looked at change of base formula. So change of base formula was logarithm of, say, a in base b is same as logarithm of a in base c divided by logarithm of b in base c. Uh, as usual, our entries are positive numbers and bases are different from 1. So all that it takes is that we are going to apply this in these problems, and that's all there is to it. But we are going to add an additional comment at the end as to where does this formula itself come from. So that's one level higher, especially for those of you headed toward mathematics. You want to know where your formulas are coming from, and this is also similar to that. So what do we do here? So very simple. You choose a logarithm. Well, how do you choose a logarithm? On the calculator, on Alex calculator, you have log, which stands for log in base 10, and you have ln, which stands for logarithm base e. These are available on any basic calculator. You can use any of them. Interesting thing about this formula is that this common base could be any number, and so you can apply either of these formulas. So for example, you can use log, which means log in base 10, and all that you have to do is type in this expression there. And remember, you want to do this in a single go so that you don't get round off errors. Once you're all done, all that you have to do is to round to the nearest thousandth, and then you're all done. So that's all there is to it. Let's write a few more example. What about this one? Well, you have to do logarithm of 1/5 over logarithm of 1/3. You can just type this exactly as it is. You don't need to do anything additional, but if you wish, you remember that logarithm of a fraction was a logarithm of numerator minus denominator. Logarithm of 1 was 0. Or we had another rule that logarithm of reciprocal is negative of logarithm of denominator. So same thing applies on both of these, and then if you wish to use this one, that is perfectly fine. Either of them is acceptable. Just to indicate that the other logarithm is as just good, you can do logarithm of 1/9, like in this case natural log over natural log of 8. You can enter it exactly like that. Of course, your logarithm comes with parentheses. If you want to simplify a bit of it by hand, be my guest and you get that result. Same story here. It's going to be logarithm of 4 over logarithm of 1/7. That's just as good as it is, or logarithm of 4 over minus logarithm of 7. So that's it for this section. These are the examples. This is the formula, and one level higher up. So we are going to go off on a tangent. If you want to come along, that would be great. So the question is, well, where does the formula itself come from? Okay, so logarithm of a over b is logarithm of a in base c over logarithm of b in base c. And the question is, well, why is that so? Let's go try to dig a little bit. uh, so when we write logarithm of a in base b, let's call it x, number x. What does that mean? It means a is b to power of x. You remember from the definition of logarithm. Same with all of them. So logarithm of a in base c, suppose we say that is some number z. What does that mean? It means a is c to power of z. When we say logarithm of b in base c, let's call this one y. Well, what does that mean? It means b is equal to c to power of y. So what this formula says, x, that's logarithm of a in base b, is equal to logarithm of a in base c, which is z, over logarithm b in base c is y. In other words, z is equal to xy. Well, let's see how. Well, where do I see z? I have a is equal to, so I'm going to write this, a is equal to c to power of z. And here I have a is equal to b to power of x. B itself is c to power of y. And now you remember rule of exponents. If you have a power and then an x power, what do you do with these two powers? You of course multiply them. Is that right? Now let's set both of these, which are expressions for a, equal to each other. C to power of z has to be c to power of yx. The only way this happens is that the exponents are the same, that is z is equal to xy, which is what we are saying here. A bit convoluted perhaps, but that's how it goes. So really, where does this formula come from? The crucial aspect of all of this is this rule that you remember from the rule of exponents, that if you have an exponent and another exponent, the two of them multiply. For example, if you have 2 to the power of 3 to the power of 5, what is that? It's 2 to the power of 3 times 5, that's 15. You remember that rule of exponent? So change of base formula is in fact nothing other than this rule, that if you have m to the power of n to the power of say k, this is same as m to the power of nk. These two are expressing same fact, even though they look, on the face of it, they look so different from each other. Okay, so that was an additional remark as to where the formulas come from, and for students in mathematics to pay attention to these, or if you are headed toward so-called theoretical engineering or theoretical computer science and so on, you want to be comfortable with these kind of arguments. But for everybody else, just the knowledge of the formula is sufficient, and that's essentially all you need. As we said, there are three logarithm formulas that are special. There's logarithm base 10, logarithm base e, and in computer science, there's a logarithm base 2. Some books have special notations for them, perhaps LG or something. So the logarithm base 2 doesn't show up on any calculator. How do you do it? So if you have logarithm of anything x in base 2, what we learn is you just take a logarithm of x, divide by logarithm of 2, and then you're all set. Okay, so that's the end of the lecture today, and good luck and God bless until next time.